Find the solution of d squared minus 2d plus 1 acting on y equals x e raised to x sin x. We have auxiliary equation equals m squared minus 2m plus 1 equals 0, which has repeated roots m1 equals m2 equals 1. Therefore, complementary function will be e raised to x multiplied to c1 plus c2x, where c1 and c2 are arbitrary constants. You can even write complementary function as e raised to x multiplied to c2 plus c1x. In order to find out pi, we have 1 by f of d acting on RHS. You can treat the RHS as e raised to x multiplied to the function x sin x. Therefore, we will have e raised to x taken outside the operation of 1 by f of d plus a, and 1 by f of d plus a will act on x sin x, where a is the coefficient of x which appears in the power part of exponential function. For e raised to x, we have coefficient of x will be 1. Therefore, a equals 1, and hence wherever capital D appears in f of d, it will be replaced by capital D plus 1. Hence, we have the new operator which acts on function x sin x will be 1 by d plus 1 the whole square minus 2 times capital D plus 1 plus 1. On simplification, the denominator becomes capital D square. Since 1 by d is integral operator, we have 1 by d square equals double integration with respect to independent variable x. Integration x sin x is carried out using integration by parts. First function x is written as it is, integral of sin x which is negative cos x is written here, minus derivative of first function which is 1, and integral of negative cos x which is negative sin x is written here, and we have again the integration is to be carried out with respect to independent variable x. That is, negative integral of x cos x plus integral of sin x is to be evaluated. In order to evaluate integral x cos x, again we will implement integration by parts. First function x is written as it is. Second function cos x is integrated with respect to x, which will give us sin x, minus derivative of x is positive 1, and integral of sin x equals negative cos x, which becomes the second term. We have integral of sin x equals negative cos x, which is written here. Here we have a negative sign which is common to both the terms. Thus, we have e raised to x gets multiplied to negative x sin x, negative cos x, negative cos x. That is, pi equals e raised to x multiplied to negative x sin x minus 2 times cos x. We have general solution will be sum of pi and complementary function. In order to find out 1 by d square acting on x sin x, this particular rule may also be used. Since we have the function x sin x is of the format x multiplied to a function on independent variable x, if you consider capital V equals sin x, then we have 1 by f of d acting on x v equals x multiplied to 1 by f of d acting on v plus derivative of 1 by f of d with respect to capital D acting on v. We have f of d equals capital D square and capital B equals sin x is considered. Therefore, applying the rule, we obtain 1 by d square acting on x sin x becomes x multiplied to 1 by d square acting on sin x plus derivative of 1 by d square with respect to capital D, which applies on sin x. We have 1 by d square equals double integration with respect to x. We have double integral of sin x equals negative sin x. Derivative of 1 by d square will be minus 1 by d square the whole square, along with derivative of d square which has to be written in the numerator. Thus, we obtain derivative of 1 by capital D square with respect to capital D will be negative 2d upon capital D the whole raised to 4, which becomes negative of 2 by d cube acting on sin x. 1 by d cube becomes triple integration with respect to x considered on the function sin x. Already from the first term, we have double integral sin x is obtained as negative sin x. Third time, when you integrate negative sin x, you will get negative cos x. Therefore, the second term becomes negative 2 times cos x. Thus, we have 1 by d square applied on x sin x equals negative sin x minus 2 times cos x, which is exactly the same expression that we have obtained. Therefore, pi will be e raised to x multiplied to negative x sin x minus 2 cos x.